I want you to hold out an empty cup. What is inside it? You say air. Okay, let's take the air out. Now you have a vacuum. You say nothing. But quantum mechanics says you are wrong. If you could look closely enough at that empty space, down to the Planck scale, you would see a violent storm. You would see virtual particles popping in and out of existence. Matter and antimatter, electrons and positrons. They appear, they borrow energy from the universe, they collide, they annihilate, and they vanish. This happens trillions of times a second in every inch of space. Empty space is not empty. It is a boiling soup of quantum fluctuations. And this soup has energy, a lot of energy. In fact, when physicists use quantum field theory to calculate how much energy is in that empty cup, the number they get is terrifying. The math suggests that the energy density of nothing is infinite, or at least astronomically high. According to the equations, there is enough energy in a single coffee cup of empty space to boil all the oceans on Earth instantly. There is enough energy in a sugar cube of vacuum to blow up the Milky Way galaxy. This is called zero-point energy. It is the baseline hum of reality. But here is the problem. If space is so heavy, if nothing weighs so much, why doesn't it crush us? According to Einstein's general relativity, energy has mass, and mass has gravity. If the vacuum energy was really that strong, the gravity of empty space should be so intense that the universe should have curled up into a ball and collapsed billions of years ago. The universe should be the size of a proton, but it isn't. The universe is huge, and it is expanding. This means our calculation is wrong, but not just a little wrong. It is the most wrong calculation in the history of science. How wrong are we? When astronomers look at the universe, they measure how fast it is expanding. This expansion is driven by the actual energy of empty space, which we call the cosmological constant, dark energy. The observed value is very, very small. It is almost zero, just enough to gently push the galaxies apart. Now let's compare the two numbers. Theoretical prediction, quantum mechanics, 10 to the power of 113 joules per cubic meter. Actual observation, astronomy, 10 to the power of 9 joules per cubic meter. The difference between these two numbers is 10 to the power of 120. That is a 1 with 120 zeros after it. This is the vacuum catastrophe. It is the biggest mismatch in physics. Imagine you tried to estimate the weight of a grain of sand, and your math told you that the grain of sand weighed more than the entire observable universe. That is how wrong we are. It means one of two things must be true. Option 1. Our understanding of quantum mechanics is fundamentally broken. Option 2. Our understanding of gravity is fundamentally broken. We have two rule books. The quantum rulebook, for small things, works perfectly. The relativity rulebook, for big things, works perfectly. But when we try to combine them to measure empty space, they scream at each other. It suggests that there is a massive piece of the puzzle missing. So where did the energy go? How do you take a number like 10^120 and reduce it to almost zero? One theory is supersymmetry. This theory suggests that for every particle we know, like an electron, there is a hidden superpartner particle, a selectron, that we haven't found yet. These partner particles would have the exact opposite energy. So, if the vacuum creates a positive energy spike, the superpartner creates a negative energy spike. They cancel each other out perfectly. +1, -1, 0. It is a beautiful, elegant solution. It makes the math work. But there is a problem. We built the Large Hadron Collider to find these superpartners. We smashed atoms together at light speed. We looked for them. And we found nothing. Supersymmetry is dying. The particles aren't there. So, we are back to square one. Some physicists have turned to the multiverse again, the anthropic principle. They argue, maybe there are billions of universes. In most of them, the vacuum energy is high, and the universe instantly explodes or collapses. Life never evolves. We live in the one rare freak universe where the energy just happened to cancel out to almost zero, allowing stars to form. It's the lottery argument. We are here because we are the winners. But this feels like cheating. It feels like giving up on finding a reason. You might be thinking, is this just math? Is vacuum energy even real? Yes. And we can prove it with an experiment called the Casimir Effect. Take two metal plates, polish them until they are perfectly flat. Place them extremely close together in a vacuum, micrometers apart. According to classical physics, nothing should happen. There is nothing pushing them. But in reality, the plates are pushed together. Why? Because the gap between the plates is so small that only small virtual particles can fit inside. But outside the plates, all sizes of virtual particles are popping into existence. This creates a pressure difference. There is more nothing on the outside than on the inside. The nothing on the outside crushes the plates together. We have measured this force. It is real. This proves that the energy is there. The vacuum is alive. Some sci-fi writers speculate that we could one day tap into this. Zero-point energy modules. Getting free. Infinite energy from empty space. If we could solve the vacuum catastrophe, we might unlock the ultimate power source. Or we might realize that we are swimming in a sea of energy that is actively trying to crush us, and we are only saved by a mathematical miracle we don't understand. The next time you look at an empty room, remember, it isn't empty. It is full, it is heavy, and it is hiding the biggest secret in the universe. I am your host. Fear the nothing. Subscribe.